Bonjour à tout le monde. Euh, Merci à ceux qui se joignent déjà à nous pour ce webinaire, pour cette formation. Nous vous remercions déjà de votre participation. Nous allons commencer dans un instant le temps pour nous de donner l'opportunité aux autres de se joindre à nous. Nous savons que c'est une journée de travail pour les uns et pour les autres. Nous allons juste vous demander de patienter encore quelques minutes. Je dirais à mon niveau 2 minutes, à maman 2 minutes encore et nous allons commencer. Dès que vous vous joignez à nous, n'oubliez pas de choisir votre langue d'interprétation. Vous avez la possibilité de choisir entre le français ou l'anglais. Il y a une petite image du globe qui est juste en dessous de votre écran et vous pourrez cliquer dessus et choisir français ou anglais. Et là, vous saurez dans quelle salle vous êtes. Et comme je suis en train de parler en français, vous allez certainement choisir français et vous pourrez aller dans la salle où vous allez suivre l'interprète parler français. Vous pouvez aussi arrêter votre micro, l'opportunité, pour ne pas qu'on entende les bruits qui viennent de vous ou alors de votre environnement. Hi everyone, we warmly welcome you to this training, to this webinar. We are about to start, let's say in 1 minute. Yeah, in 1 minute we shall be starting. So we plead with all those who are already connected to choose their translation room. You have a small icon down on the image and you can see there on your screen the image of that icon, the icon of the globe where you can click and choose the language, either French or English. So don't hesitate to choose your language and yes, you shall be in the room where you'll be able to hear the training in your language. We thank you. You can already also introduce yourself in the chat, your name, your organization, your country, so that we shall be knowing from where you are coming from. Comme je le disais tantôt en français, nous vous prions de laisser dans le chat votre nom, le nom de votre organisation, le pays d'où vous venez ou alors d'où vous suivez cette formation et ça nous fera plaisir de vous souhaiter la bienvenue. Ok, Rose, bienvenue, Rose du Zimbabwe. Bienvenue, Conrad de Chai. Bienvenue à tous. Vous pouvez également partager le lien à vos contacts pour qu'ils puissent se joindre à nous, parce que comme nous allons commencer d'un moment à l'autre. Juste quelques secondes encore, disons 5 secondes, et nous allons effectivement lancer le webinaire. Vous pouvez partager le lien à vos contacts pour qu'ils puissent également se joindre à nous. N'hésitez pas surtout de checker votre connexion. Dans 5 secondes, on va commencer. N'hésitez pas de checker votre connexion. Si votre connexion n'est pas très stable, vous pourrez ne pas écouter. Je pense qu'on va commencer tout de suite. I think we are going to start. Yes. If you are there, don't forget, we are going to start in a few minutes. As I was saying earlier, please check the translation box, click the box, the room where you belong to, either French or English. And yes, you'll be able to hear the training in your language, your correspondent language, please. And don't forget to send in the chat your name, the name of your organization, the country where you are coming from. Pour les francophones, vous pouvez cliquer sur la petite icône du globe qui est sur votre écran juste en bas. Vous pouvez choisir la langue qui vous convient. La langue qui vous convient, vous verrez en dessous également soit français, soit anglais, et vous choisirez la langue qui vous correspond. Donc, nous allons effectivement lancer. Hi, everyone. It's our pleasure once again to welcome you for this webinar, for this first session of our training webinars for the year within your CS4Me group. and coalition. We are so glad to have you connected today. Today, we are going to talk about a very special topic: resistance in the fight against malaria, causes, challenges, and remedial actions. You know, today is not just a common topic, and that's why we brought for you, and only for you, an expert, Dr. Magellan Tchouakui, who is a researcher at the Center for Research in Infectious Disease called CRID. He will be with us. He will tell us more about resistance in the fight against malaria, and you shall be able to answer, to ask your question, and he will give you appropriate answers. To start this webinar, I want just to give you some useful information or tips. We plead with you to off your microphone and open it only when you want to speak. That will help us not to have noises that are coming from your environment. Another thing is that this 1 hour webinar will be simultaneously translated in French and in English. Please choose your language by clicking on the icon with the form of the globe and enter your room, whether French or English. And as soon as you enter the webinar, confirm your presence by entering your name, organization, name, and country in the chat box. There is a QA box, question and answer box, as well as there's a chat box. And please, we will also like you to give us your consent, because this webinar will be recorded. Just to show you few images in blue, how to off your microphone. You can also see the image of the interpretation icon where you choose your language. You can also see the third image at your right. That is the image of the Q&A box. And down, you can see the chat box where you can click if you want to send your messages. Now I'm going to present to you right away the agenda of the webinar, which are already in the housekeeping and modalities when I was talking about choosing your room and other stuff I talked about earlier. And after that, we are going to take the closing remarks from Fidel Bemadou of the CS for Me Secretariat. You already know Fidel. I know that many of you knows him. And we are going to enter and take the main dish that will be coming from our expert, Dr. Magellan Tchouakui. And one of the most important part of this webinar is the round of discussions. That will be the place and the opportunity for you as participants to ask all your questions. And be sure and be assured, I myself, I'm sure I will have many questions. And at the end, we are going to have a closing remarks. And then after, we shall separate and take the appointment for the next webinar. Right away, without wasting time and without much further ado, I want to introduce here for you our guest for this first part, the one who will give us the welcome remarks. Here I'm talking about Fidel Bemadou. Few minutes and he shall be here.
Thank you so much, Martin. Merci beaucoup. Mettre les bases au webinaire très intéressant. J'ai déjà dit, j'ai dans la bouche en entendant ce jour sur une pratique très importante de la distance. Ce problème est devenu de plus en plus récurrent dans les pays endémiques qui contribuent fortement à la recrudescence des nombres de cas de paludisme et malheureusement des décès liés à cette pandémie dans nos pays. Donc, ce jour, nous avons l'opportunité, nous avons l'infini honneur d'avoir un chercheur de haut rang qui va pouvoir nous édifier sur cette thématique qui, jusqu'à présent, entretient encore certains mystères. Nous ne comprenons pas réellement, quand on parle de résistance, ça veut dire quoi concrètement? Pourquoi est-ce que ces moustiques sont résistants? Pourquoi dit-on que certaines populations sont résistantes aux antibiotiques ou bien que certains médicaments ne fonctionnent plus dans certaines zones pour telle ou telle raison? Donc, nous aurons l'opportunité au cours de ce webinaire de nous entretenir sur toutes ces questions avec l'expertise d'un chercheur à l'échelle mondiale qui pourra mieux nous édifier sur cette question. Je ne vais pas prendre beaucoup plus de temps. Je vais laisser le soin à notre expert qui va être introduit par ma collègue Martine afin de nous édifier clairement sur sur ce sujet. Donc, Dr Magellan, nous allons vous dire merci une fois de plus pour votre disponibilité et surtout pour votre intervention au webinaire de ce jour. Je vais d'abord laisser le soin à Martine de pouvoir vous introduire clairement avant de vous passer la parole. Merci et à Martine.
Okay. Thank you so much, Fia. And yes, thank you so much for the question. Just we wish you welcome to this webinar. We are going to proceed without much further ado. We are going to introduce right away our expert for today, Dr. Magellan Tchouakui. I think I am not really qualified to introduce him. He's going to introduce himself to us. And yes, I will just make sure I also prepare my questions because I'm sure I will have a lot of questions for this. So I will have to stop my screen share so that our expert shared his screen and we dip right inside the presentation. Over to you, Doctor. Thank you.
Thank you so much, Martin. Once you stop to share the screen, I will share mine before starting to introduce myself and then share with you what I've prepared for this morning. Okay, thank you. Can you confirm if you are getting my screen and hearing me well?
We can see your screen very well.
Yeah, are you getting me as well?
Yes, we are getting you.
Thank you so much, Martin and CS for me, Isa, for the opportunity to share with the audience some few informations about resistance to insecticides and the impact on vector control. As you said, I am Magellan Tchouakui, a research scientist at CRID, and also a Wellcome Trust Fellow at the CRID and the Liverpool School of Tropical Medicine. I got a PhD in the molecular biology or molecular entomology, where I was trying to look at the potential fitness costs associated to resistance to see if one mosquito is resistant to insecticides that may affect some key life threats, such as the longevity and other parameters in order to influence malaria transmission. After that, I started a postdoc with Bill and Melinda Gates Foundation project at CRID, where I was trying to look at the potential molecular basis of resistance to insecticides to see how we can anticipate with the novel insecticide coming, if you can have molecular drivers and the diagnostic tools to track that will help to preserve their effectiveness. I'm also providing a lot of technical support to companies like Bayer, Syngenta, and many other companies who are producing insecticides. So we are having facilities at CRID where I'm conducting or assisting in testing some of the new insecticides they are putting in pipeline. I also provided some few support to PMI Vectoring in Cameroon, where I was assisting in not only preparing insecticide, but also doing some field testing and lab analysis of subsample collected. Today, what I will share with you is really about insecticide resistance. When we talk about resistance, what is that? How can that appear in mosquito population? What is the impact on vector control interventions, and what are the actions to be taken to mitigate that issues of resistance? So in this first slide, is mainly just to remind us that malaria remains an important public health concern in Africa, where we are having more than 95% of cases. And you can see here that Cameroon is among the countries with the very high burden. So each year we are having nearly 3 million cases confirmed, which is leading to a lot of deaths. And in the health centers, malaria remain like or constitute about 28% of all consultations, showing that we still have a lot of work to do in fighting against malaria. But what we can notice is that since 2000 to 2015, we have been having a significant reduction in malaria burden at the level of mortality, morbidity as well, as we can see on the first picture on our, let me see if I can have something to point it. So on this first picture, you can see that we have been having a significant reduction since 2000 to 2015 or 10, and this has been mainly due to the large use of vector control interventions like bed nets. So I'm sure each one of us in our houses, we have at least one bed net. So this massive use of bed nets helped to reduce significantly this burden from that time. But as you can see here, suddenly we noticed an increase from 2015 to now. You see that the number of cases due to malaria is increasing. And during the presentation, we will understand why we are having this increase. Even in the term of mortality, you can see that we are having some increase in terms of mortality due to malaria. And also malaria is causing a lot of economic losses, because people, when they are sick, things like that, they cannot go to work, they cannot do business, and this is causing a lot of economic losses. And on this picture on our right, you can see that despite the fact we are having meetings, tons of meetings and conferences to try and find a solution to reduce malaria burden, we are very off track from the vision of WHO to eliminate malaria by 2030. You can see that we are like 48% off track from the vision to eliminate malaria, showing that urgent actions need to be taken at this stage to keep reducing the trends we had in the beginning. So people will ask, what are the key elements leading to that? As I said initially, we have resistance of mosquitoes to insecticide, which is one of the main factors preventing the reduction we had, because initially, like 80% of the reduction was due to vector control, but now as mosquitoes are becoming resistant, we are having some cases where mosquitoes, which in the beginning were susceptible to interventions, so when they came in contact with the bed nets, they were killed. But you can see that now, most of them are just very happy when they're on the bed nets. They can take the blood, they're able to go and lay eggs, and the progeny will develop and be able to transfer the genes to the older generations. So maybe before defining what is called resistance and the other aspects, I would like to mention that on top of the fact that mosquitoes are resistant to the insecticide, which is the main factor leading to failure of vector control interventions, you have also lack of access to diagnostics and treatment, because you know in Africa most of people are poor and even the conditions are not good. That's why we can have those increase in terms of malaria transmission. But you also have poor quality of drugs, because all drugs are not of good quality, and this is leading to not only resistance, but preventing us to achieve the objectives to eliminate malaria. We have also the fact that most of the vector control interventions are mainly based indoor, but we have also the cases where mosquitoes, they are able to bite outdoor. So when people are still like maybe in the kitchen cooking or taking some beers outside, they can be bitten by mosquitoes, and this will contribute to sustain the transmission in the population. We are now having also the issues of this invasive species called Anopheles defensi, which is increasing the case of malaria, particularly in the Horn of Africa, and is spreading through Western and Eastern Africa. So all these elements are the major factors contributing to that, to the fact that malaria is not reducing anymore. On top of that, we have the issue of climate change. which is another big factor contributing to sustain to the stagnation of a reduction in malaria burden in Africa. So let us come back to resistance. As I was saying, mosquitoes in the past, when they came into contact with the bed nets or other insecticide-impregnated interventions, they were killed by the insecticide. But now they're able to withstand, to blood feed, and even to survive 10 times the diagnostic dose recommended by WHO. So we have been having what we call the escalation of resistance to the vector. But the resistance itself is something like you have a normal population, but in some cases, some of the individuals in that population will be able to survive. And it's only called resistance once that is leading to failure of interventions, and if the molecular mechanisms or the genes or the mutations causing that resistance will be transferred to the next generation. If you don't have those two elements, if it's not able to be transferred to the next generation, you cannot call it resistance. And also, if it's not leading to the failure of interventions, it's not really called resistance. So we need those two elements to talk about insecticide resistance. In the next slides, will be talking about the main causes, what is causing that resistance, how does that appear in mosquito populations, what are the different mechanisms of resistance, do we have only a single way by which mosquitoes can be resistant to insecticides? What is the impact of that resistance on various interventions, and how we can mitigate that phenomenon in order to gain success in vector control? Before moving to that, this is just to share with you some history of vector control, because resistance came from vector control. And here we have the man who discovered the first insecticide used in public health, which was DDT. And this was mainly used, this is Miller, got a Nobel Prize by discovering that insecticide. So DDT was the first insecticide which was used in vector control, particularly in the years 1944. And this was mainly used in the US, in Italy, where these insecticides show a very high efficacy and help to control vector populations. Based on that success, many African countries like Kenya, Nigeria, and many others, even in Cameroon, started using that insecticide. And you can see that at the beginning, when they implemented the DDT, you had a lot of reduction in malaria burden till the years 1960. So like 20 years after using DDT, we noticed that the number of cases due to malaria was increasing everywhere. You can see all graphs. From that year, you had an increase in terms of number of cases because DDT have been used for many years, and we only had that insecticide at that time. After that, in the years 20, based on, due to the fact that WHO noticed that DDT was not working anymore in IAS products, they recommended the bed nets, which was at this time impregnated mainly with pyrethroid insecticides. And we have tons of bed nets which have been distributed across the world, and particularly in Africa, where we had nearly 3 million of bed nets distributed. And this was quite suitable of protecting indoor biting mosquitoes. Also, we had another interventions, which is IRS, as the one we did with DDT. But this time, this is using other insecticides like carbamate, like pyridophos methyl, which are other classes of insecticides. But you can notice that bed net was only recommended to be impregnated by pyrethroids, because pyrethroid is very fast acting. Once mosquito come into contact with bed nets, the insecticide contained in this bed net will produce what we call the knockdown effect. So mosquitoes will be knocked down and fall on the floor. Even if mosquitoes does not die immediately, it can be eaten by ants and many other parameters, which will help to reduce their density in the population. Another fact is that pyrethroid insecticide used in this bed net is very safe for human, because you can see this guy, people are in contact with the bed net, so we need something which is safe for human. For IRS, we mainly put that on the wall because it doesn't provide the same level of reduced toxicity for human. That's why people could not go directly into contact with those insecticides. So we are mainly interested here in pyrethroid, which have been the massive use in the last 20 years. as you can see here in this graph at your right, the first one on the top, in one of the very important studies, it has been shown that the reduction you had in the past in reducing the burden of malaria was mainly due to bed nets in green here, as you can see. And on top of that, you had ACTs, you had also indoor residual spraying, but the majority, like 70% of all reductions, was mainly due to bed nets, as you can see also on the picture down. Now, what is happening since 2015? Because we're having the reduction we started having in the past is now like you can say stable or even tend to increase. It's just that at the beginning, when people started using bed nets, the pressure of insecticide or the insecticide selection pressure was very low. And in that case, so even the number of people having bed nets was low. So it did not have that high level of selection pressure on the mosquito. That's why they remain quite susceptible, and we have been having a good success in reducing the cases. But more people continue using those interventions with like massive use of insecticides. You can see that here you have high ownership of insecticides, and that constitutes like a high selection pressure to the population because that was impregnated only with a single insecticide. And that's constitute like a high selective pressure because mosquitoes are, we know that is not just a normal phenomenon. If mosquitoes is exposed to something which is toxic, they will always find a way to survive or to escape. And you can see that this is leading us to what I presented initially, very off track from the vision of the WHO to eliminate the disease by 2030. That's why we need some innovation, particularly understanding what is causing that resistance, what are the genetic factors, and how can we successfully manage resistance and even preserve the effectiveness of the new tools in the pipeline. You can see here, this is for pyrethroid. At the beginning, in the years 2000, you can see that a lot of places were green, but with time, you can see that they become red because resistance is escalating in the vectors. So, and in order to avoid the same situation for all the new interventions coming, we need really to improve the understanding on the molecular drivers of resistance. And you can see that WHO in this report said that if nothing is done to really understand how resistance appears and find a way to mitigate that, this is where we will be in the 2040. So we continue having increase in malaria cases. This is the current trends where we are. So WHO is saying that if you can clearly understand how resistance appears in the mosquitoes and find a way to mitigate that, you can achieve elimination by 2040. In this, as you can see here in 1 and 2. So that's why the presentation of today is very interesting because it will help us to understand how resistance appears and what are the impacts, what are the way forward, how can we do to mitigate that resistance. So here is just to show you how resistance can appear in mosquito population. So at the beginning, before we implement any insecticide-based intervention, we have some rare cases where we have some individuals in red here in the population. They are already able to survive to that insecticide just because of their genetic makeup. So they have that ability, what we call natural selection. They have the ability already to survive. But if you start with that intervention, those in green, which are the susceptible ones, so they are susceptible to the pollen you are putting, they will die, and then the frequency of those in red will increase in the population. And if you continue with the same intervention, you can see here that with time, all of our population will become red because they have acquired the insecticide-resistant genes from other individuals here. But in the management or in the approach of managing resistance, we have like 3 main strategies that the WHO recommends. We have what we call rotation of interventions. So you can use one intervention like for 3 years or 4 years, but when you notice that your population is becoming resistant, you can shift to another intervention. In that case, you will have what we call reversal of susceptibility. Your population will become susceptible. And unfortunately, in the past, we did not have a lot of insecticide to be able to rotate. But now that we are having more and more insecticides recommended by the WHO, like the chlorpheniramine and many others, we are now able to rotate between pyrethroids and those new insecticides just to avoid using an insecticide for a very long time. Pyrethroid, for example, have been used now for 20 years. That's why resistance is spreading everywhere, and we are having reduction of the efficacy of interventions. So here was just really to show you how resistance can appear in mosquitoes. And to become resistant to insecticide, mosquitoes will develop a lot of strategies. And among the strategies, the first one, or the major one, causing failure of interventions, is what we call metabolic resistance. So in the case of metabolic resistance, mosquitoes will just try to degrade the insecticide because before it even reaches the target. So mosquitoes will be degraded and eliminated. The second one is what we call, in blue here, is what we call target site resistance. Mosquitoes will just change the target site where the insecticide was supposed to bind and then kill it. It will change the configuration so that the insecticide will be not able to reach the target. So these are the two major mechanisms which are very well studied and well understood. But on top of that, you have what we call behavioral change. So mosquito can just change his behavior to avoid to come into contact with the insecticide. So, for example, instead of biting during the night, mosquitoes will now choose to bite maybe in the evening when people are still out, or maybe early in the morning when people leave the bed net or other interventions. They can also change their resting place. So mosquitoes that we know that normally they are indoor, they bite people when they are sleeping during the night, they will prefer to bite them outdoor before they even go to bed. They can even change the behavior of the hosts they used to take, so they can multiply the host. Mosquitoes initially maybe which were only taking blood on animals or things like that may change the behavior and now start biting on humans and many things. So that we call behavioral change. On top of that, we have what we call cuticular resistance. So they can change the composition of their cuticle to make it very tiny, very thickened, so that the insecticide will be not able to penetrate and kill the mosquito. So that will appear at the level of the abdomen, but also the antenna and the legs, just to avoid the insecticide to go through and kill the mosquito. So the big challenge now in addressing all these issues is to have something that we call molecular markers, like a diagnostic tool which can help you really to detect at the very early stage when you have that resistance. So the big challenge is to have the molecular markers for this resistance to be able to easily track it in the field, assess the impact on interventions, look at how to implement good resistance management plan and all those elements. As I was saying initially, these are the summarized mechanisms. You have the target site where you have the change in where the insecticide was supposed to bind and kill the mosquitoes, so the insecticide will be not able to bind here. For the metabolic, I'll just insist on these two big major resistance mechanisms. For metabolic, in yellow, you have the insecticide resistant genes, which will be able to break down the insecticide before it even reaches the target, as you can see here. So these two mechanisms, a lot of success have been done. For the KDR, for example, the first molecular markers was detected in the 1998, and the second one in the 2000. So this is like 24 years now. And since then, it was not possible to detect molecular markers for the other resistance mechanisms. But our team, CRID, and the other team at the Liverpool School and elsewhere have been able in these recent years to detect molecular markers of resistance to the other group, particularly for this metabolic resistance. Because for metabolic resistance, you have like 200 enzymes or genes which are helping mosquitoes to survive, and they belong mainly, so don't bother too much yourself about all this. The key elements here is just to understand that genes conferring resistance to mosquitoes for metabolic belong to 3 main classes or 2 main families. You have what we call the P450 genes. We have the glutathione S transferases here, and then we have the esterases. So all the 200 genes that are helping mosquitoes to survive belongs to these 3 groups. And the big challenge now have been, in the past have been to have something like the diagnostic assay, which can help you to really detect the resistance at the very early stage and be able to make recommendations to control programs. Now that we are having a lot of new interventions coming, it will be vital to have those molecular markers to be able to see if there's any chance of cross resistance, if resistance to pyrethroids may affect the efficacy of these new interventions. We have, for example, here the spatial repellent that CRID actually is negotiating a grant with the UNITAIDS in collaboration with the CSOM to introduce this spatial repellent into the vector control strategy. And it will be good at this stage to see if resistance to pyrethroid will affect the efficacy of these new interventions. That's why having molecular markers, as I said initially, can help really to anticipate. We are having tons of other interventions. We have dual active ingredient nets, which is made of.
Doctor, it's like we miss you few minutes. If you can just
Okay.
record,
Yes, okay.
It's just like we miss you few minutes.
Where was it, please? Was it here?
Yes, if you can come back to it, yeah.
Okay, thank you so much. I will do it, Martin. So I was just saying that this one, don't bother too much yourself on this. It's just to mention that the genes or the genetic factors helping mosquitoes to survive to insecticide belongs to 3 different families. You have the mutation S transferases here. You have the P450s, the cytochrome P450s, and then you have the esterases. And the key challenge now for researchers and for control programs and others is to have something like we call the molecular drivers or the diagnostic assay, which can help to detect these genes at the very early stage before they start causing failure of interventions. And this is very important because we are having a lot of new interventions coming in the pipeline. For now, we mainly have what we call dual active ingredient interventions like the interceptor G2 and the permanent dual, which are the nets combining now 2 insecticides. The first one is having chlorphenapine and alpha-cypermethrin, which are the two insecticides. The second one combine chlorphenapine and detamethrin. So these new insecticides are already distributed in Cameroon. And if you have those molecular markers of resistance, something which can help you to detect resistance to insecticides, you'll be able to really track as these interventions are implemented in the field, see if resistance is appearing, if it continues to be efficient and things like that. And you can do the same for all those new interventions coming. We have spatial repellents that CRID and CS4Me are now discussing or negotiating a grant on with UNITAID, which will be something to scale up and include in the vector control intervention. So it's important to have those molecular assays to be able to see if resistance to pyrethroid is affecting their efficacy. So CRID is working extensively on that aspect. And here is just to share with you some of the key progress we have made at CRID by detecting molecular markers. This was the first one we detected 20 years after we had the molecular markers for the KGR. So this was the first marker of metabolic resistance, because metabolic resistance is the main mechanism of resistance causing failure of intervention. So it's important to have molecular markers for that type of resistance to be able to really help control programs saving the intervention they are having. So CRID made a significant progress. We detected this one in 2019, but unfortunately it was only based in Southern Africa, Malawi, Uganda, Southern Tanzania, not in other countries. Later on, this was for Central Africa, where we detected that marker, and we noticed that with time, this resistance is increasing in the field, and it will be important to have more markers which will help to address these important questions, and even looking at the impact of intervention. This second one was for the Western Africa, mainly for Ghana, where one of our PhD students detected molecular markers which can help now in Western Africa, particularly in Ghana, to detect metabolic resistance in the field. And National Malaria Control Program will be able to take over to see if this resistance is impacting the efficacy of the new intervention they will be receiving in the coming years. So this was the marker, as I said, it was mainly based just in the Western Africa. So you had marker now for Southern, for Central, Western, and we still needed the marker for the Eastern African parts. And another PhD student in the group, Carlos, was able to detect that marker for the Eastern Africa, and he was even able to look in the significant condition how that marker of resistance can impact the efficacy of the new interventions, not already implemented, but just to anticipate and see how that can affect. And you can see here clearly that all the mosquitoes which are able to survive exposure to that bed net, it was because they have that resistant allele for that gene. So having molecular markers is really helpful to not only detect at a very early stage, but also help to improve control strategies. We did the same for Gambia, where for the first time, we detected a marker for resistance, metabolic resistance in Anopheles gambiae. I will not go too much into this, this molecular stuff because it's quite complex, but at CRID, what is good, we have a platform, extensive platform, which can help other people to come and train and be able to detect in their own context what are the key drivers of resistance, which may lead to the failure of interventions in their settings. So this is one of postdoc in our group. He was able to detect for the first time a molecular marker of resistance in Anopheles gambiae, which is the primary African malaria vector. So he was able to detect that molecular driver and establish that that intervention or that gene, was able to, as you can see here, help mosquitoes to survive. So you see that most of those mosquitoes surviving in rats is because they have that a particular allele or variant of a gene which is helping them to survive in the presence of those insecticides. And here is just to show that at CRID also you have a lot of stations that we can use to assess how the new insecticides implemented or recommended by WHO are working, and even as we did here, see if the previous genes can help to really is having any impact on their efficacy. So for example, here you can see that if mosquitoes are susceptible, they will die when they are exposed to this intervention, which was permanent 3.0 PBO-based net, showing that PBO-based net can really work in that context. So this is another very important piece of work we did. The article will come soon for the new insecticides that the WHO is now recommending. I noticed with our research team that when mosquitoes are resistant to pyrethroids, they are very susceptible to clofenapine. So if you have resistant genes to pyrethroid, you are more susceptible here, showing that if National Malaria Control Program implement interventions with clofenapine, we'll be having a lot of success, because when you are resistant to pyrethroids, you tend to be susceptible to these insecticides. And this insecticide now is impregnated into the interceptor G2, as I said, and many countries are using that. That's why in many settings, we have been seeing high efficacy of that intervention. But the opposite pattern was seen for the clotrimazine, which is another insecticide mainly used for indoor residual spraying. If you are resistant to pyrethroid, you are also resistant to this insecticide, showing that if you implement IRS-based interventions using clotrimazine in those settings, you'll be having a failure, showing the very important aspect of having these molecular markers, because you can even assess it before implementing your interventions. And CRID have been working hard really to put to provide to national malaria control programs all these molecular assays, which will help to really anticipate on resistance. This one is another piece of work I've been doing just to try and anticipate to see what in the future will cause resistance to the new insecticide that we call clofenapine, which is very efficacious now, is very efficient at controlling the mosquitoes now. But as we know, with time, mosquitoes will find a way to resist. And what I did, I was able to detect some of the key candidate genes, which will help mosquitoes in the future to become resistant to that insecticide. And we are working now to have a diagnostic assay that will provide to national malaria control programs so that they are able to assess in their context if that resistance is appearing already. So we are still finalizing this, and in the coming months, we'll be able to publish this article and even share the report with our control programs to be able to monitor that. So this is almost among the last slides, just to show that having also markers of resistance will help you to assess and see if you rotate the insecticide in your context, it will be successful. And to do that, we have what we call fitness cost, which is one of the key aspects or the prerequisite that your population need to have for the success of rotation of insecticides. For example, here, for a key insecticide resistant genes that we call type 6P9A, I show that with time, if you remove the selection pressure of the population, the frequency of that gene will reduce in the population. And in that case, if you can come back maybe after 2 years, change the strategy, you'll be able to recover the susceptibility and maintain the level of resistance very low in the population. And because of that, I've been able to get this funding from the Wellcome Trust Fellowship to be able to assess for other genes and also look if there are some elements which can help to reduce this cost of resistance so that we don't have that reversal of susceptibility. So in summary, what I would say is just to mention that vector control remains a cornerstone in the fight against malaria, but the success is threatened by the emergence and spread of resistance. Therefore, there's a huge need to develop molecular markers or diagnostic assay, which will help for early detection and monitoring of resistance in the field, which will help control programs to assess the impact of that resistance on various interventions, which will help to assess the potential cross resistance between interventions to see if pyrethroid resistance may affect the efficacy of the new interventions coming. And that also will help to establish the fitness cost in the prospect of insecticide resistance management in order to accelerate malaria pre-elimination. So thank you so much for your kind attention. I'm sorry because I took a lot of time than what was given. This is the CRID team working beside what I presented, and thanks also to all our partners, including CS4Me and all other partners. Thank you so much for your kind attention.
Thank you so much, Doctor. Thank you so much. You are not going yet? No. We already
I'm still with you.
Yes, we really thank you to open up this series of webinars we shall be having on this platform till the month of December. And the topic will be interesting as we will be going forward. So I will already just open up the floor now for people to ask questions. I think I will switch in French because I have a French-speaking participant who asked a question. For him to feel really comfortable, I will call on him in French, so I will switch in French right away.
Good.
Albert, vous avez
answer
posé
in
une
French
question dans
to
le
make
chat.
sure.
Est-ce que vous pouvez peut-être ouvrir votre micro et poser votre question directement à l'expert qui est encore avec nous? Albert Bonnet, est-ce que vous êtes avec nous? Vous pouvez ouvrir votre micro et poser la question, votre question. Pour ceux qui ont des questions déjà, vous pouvez lever la main, vous pouvez ouvrir votre micro et nous allons... vous pouvez lever la main et nous allons ouvrir votre micro pour que vous puissiez poser votre question. Docteur, je pense que je vais poser la question d'Albert, peut-être qu'il est plus connecté. Il souhaitait savoir, est-ce qu'il serait possible de faire une telle étude au Burundi comme cela a été fait au Ghana dans votre présentation?
Okay, merci beaucoup, Martine et Albert, pour la question. La question est très intéressante. Et comme je l'ai dit au départ, le CRID travaille non seulement au Cameroun ou alors dans les pays où j'ai mentionné, nous travaillons également avec le Rwanda et d'autres pays. Donc, c'est très possible, si nous avons des moustiques provenant du Burundi, déjà pour le premier marqueur que nous avons détecté, ou alors pour ceux qui existent déjà, il serait possible de voir si ces marqueurs existent déjà au Burundi et également regarder sur les interventions qui sont actuellement en cours au Burundi, si ces marqueurs détectés ailleurs pourraient avoir un certain impact au cas où ils existent déjà dans ces localités. Mais si nous avons les moustiques du Burundis, comme je l'ai mentionné, il serait possible de détecter tous ces variants génomiques à mesure de causer la
Allô?
résistance.
Oui, il y a quelqu'un qui veut poser une question? Il y a un participant ou il y a une personne?
Oui, je
Pauline?
peux poser. Oui, c'est
Oui,
Pauline.
allez-y, Pauline,
Oui,
allez-y.
bonjour et je vous remercie beaucoup pour la qualité de la formation, de la présentation des travaux. C'est très intéressant. Mais malheureusement, moi qui suis sur le terrain, au contact des populations, qu'est-ce que je leur apporte en termes d'innovation? Parce que vous parlez des charges, de ceci, des marqueurs. Moi, je suis dans la sensibilisation. J'ai en face de moi des parents qui prennent des médicaments. Quand l'enfant a fait de la fièvre, on ne sait pas ce que c'est, on donne les médicaments. Quel message est-ce que nous leur apportons? Nous ne sommes pas tous des traitants, mais nous sommes des gens qui essayons de rapprocher les populations des agents communautaires. Donc, quel message est-ce que nous, on rapporte aux populations? Merci.
OK, merci beaucoup, Pauline, pour la question. La question est très intéressante et comme je l'ai mentionné au départ, il faut juste continuer à sensibiliser la population, de continuer à utiliser les moustiquaires parce que ça interrompt au moins le contact entre le vecteur qui transmet le pathogène et l'homme. Et malheureusement, comme je l'ai dit, c'est que ce qui fait que ces moustiquaires n'ont plus la même efficacité, c'est parce que les moustiques ont développé une certaine résistance. Mais les équipes sont actuellement en train de travailler pour mettre sur pied de nouvelles moustiquaires. Et comme je l'ai dit, plusieurs pays déjà vont vers ce qu'on appelle des moustiquaires de nouvelle génération qui n'utilisent plus seulement l'insecticide qu'on n'avait pas le passé, combinent deux insecticides
Et,
avec des modes d'action différents que les programmes de lutte peuvent distribuer aux populations parce que ces moustiquaires sont en train de montrer une meilleure efficacité par rapport à ce que nous avions par le passé. Donc, la moustiquaire a non seulement cette capacité de tuer le moustique, mais aussi de limiter le contact entre le vecteur et l'homme. Donc, pour vos populations, c'est vraiment de recommander de continuer à utiliser ces moustiquaires. Et comme je l'ai mentionné également, nous avons une étude très intéressante, ou alors un projet très intéressant que nous allons commencer d'ici peu, qui vise à mettre sur pied d'autres outils alternatifs qu'on appelle le spatial repellent, qui est un peu comme le Montaiga. On accroche juste dans la maison et ça a une efficacité de 12 mois. Donc, si ces interventions, ou à la fin de cette étude, est recommandée par l'OMS, des programmes de lutte pourront également recommander l'utilisation dans leur contexte et cela va contribuer à vraiment réduire cette transmission chez les patients.
Il y a une autre question, docteur, c'est de savoir est-ce que le changement climatique également peut être un facteur de résistance? Vous posez cette question.
Exactement. Merci
Oui.
beaucoup, Martine. Si vous vous rappelez, dans ma présentation introductive, je vais mentionner parmi les facteurs qui contribuent à maintenir la charge du paludisme dans la population. Nous avons bien évidemment l'effet du changement climatique, comme nous le voyons ici, d'après le dernier rapport de l'OMS qui dit que la plupart, ou alors les cas de résurgence ou l'absence de réduction des cas de paludisme serait en très grande partie due à ces changements climatiques. So I did not get you well. Maybe the internet connection issue.
Quand on est dans les bars, quand on est à l'extérieur, quand on est en plein air.
Oui, jusque-là, il ne vous a pas très bien suivi au début. C'est la fin qui était un peu.
OK, le participant demande comment est-ce qu'il peut se protéger contre les piqûres des moustiques en plein air,
Ah,
donc
OK.
dans les bars, dans les
Oui,
restaurants,
oui,
oui, quand il n'est pas dans
merci
un
beaucoup.
lieu où il peut être protégé.
C'est très clair maintenant. Donc, comme je l'ai mentionné, c'est que parmi d'autres facteurs, c'est le fait que certains moustiques piquent à l'extérieur des maisons avant que les habitants des maisons ne rentrent dans la maison et se fassent protéger par les moustiquaires. Donc, actuellement, il y a une très grande étude que nous sommes en train de mener pour pouvoir contrôler ces moustiques qui piquent à l'extérieur en utilisant ce qu'on appelle le Attracted Target ou Attractive Toxic Sugar Baits, qui est quelque chose comme du sucre empoisonné. on accroche à l'extérieur des maisons et lorsque le moustique va venir pour prendre, parce que nous savons, les moustiques se nourrissent premièrement du nectar de fleurs. Ce n'est qu'en second plan qu'ils prennent du repas de sang chez l'humain. Donc, lorsqu'ils vont venir chercher ce sucre sur ce qu'on appelle attractive toxic sugar beet, lorsqu'ils vont prendre ce jus sucré qui est empoisonné par l'insecticide, ça va les tuer et de cette façon réduire un peu la transmission à l'extérieur des maisons. Donc, à ce stade, il n'y a pas vraiment...
There is another question from Conrad Ekukole, who want to know if CRID is doing any research on resistance to ACTs and other antimalarial medications.
Okay, thank you so much. Yes, we are mainly doing some xenomonitoring of ACT resistance and artemisinin resistance. So you have a team working on that, and you have a recent paper published in Gene where we have been screening for the key ACT resistant markers using mosquitoes to see if those markers are already present in Cameroon and in Africa. So we are doing that mainly from the xenomonitoring parts using mosquitoes.
Il y a également un autre participant, docteur, et je voudrais demander, plaider l'indulgence de tous les participants. Vous savez qu'on a pris du temps pour commencer. Vous allez nous permettre d'étendre cette session pour 7 minutes encore, le temps de conclure. Je vous rassure qu'on ne va pas déborder. Il y a un participant qui souhaite savoir comment est-ce que vous pouvez faire cette étude également au Togo. C'est Alou Langui. Cette question vient de Alou Langui.
OK. Comme je l'ai mentionné, vraiment presque partout, si nous avons des collaborations bien établies et si nous avons des moustiques provenant de ces localités, il est très possible de le faire. Mais ce qui est là, pour les marqueurs actuels, la première des choses, c'est qu'il faut d'abord suivre dans ces localités s'il existe déjà, que ce soit au Togo, que ce soit au Bénin, que ce soit partout en Afrique. On fait une surveillance, on voit si ces marqueurs sont déjà là. Mais s'il y a besoin de détecter ce qui cause la résistance dans ces contextes particuliers, ils peuvent nous contacter à tout moment et avec la moustiques provenant de ces régions, il serait possible d'avoir des marqueurs qui aideront au programme à prendre des décisions opérationnelles.
OK, merci. Je vais permettre à Raphaël Kakmeni, qui a levé sa main, de poser sa question directement. Raphaël?
Oui, bonjour.
Je crois que... Bonjour, Raphaël, votre micro est ouvert.
Oui, bonjour. Oui, quand je suis l'exposé de l'intervenant, qui est tellement très bon, j'ai des inquiétudes. Parce que quand l'OMS fixe un cap, un objectif, on nous dit qu'il risque de ne pas atteindre. Est-ce qu'on ne serait pas en train d'être à l'éternel recommencement? S'il y a déjà l'inefficacité, entre guillemets, de l'actuel moustiquaire, est-ce que on ne sera pas en train c'est-à-dire, est-ce qu'il n'y a pas échec dans la recherche?
Oui. Mhm.
Ou
Je vous ai saisi très bien.
Mhm.
Oui, oui, je vous ai saisi. Donc, comme je l'ai dit, c'est vrai qu'il y a résistance, mais on ne va pas rester, on ne va pas croiser les bras et rester sans rien faire. Parce que je vous ai mentionné, depuis les années 2000, les moustiquaires marchaient très bien, mais malheureusement, en ce moment, nous n'avions qu'une seule classe d'insecticides. C'est pourquoi la résistance, vraiment aujourd'hui, est répandue à travers l'Afrique pour cette classe d'insecticides. Mais si vous voyez sur cette diapo que j'ai mis, que j'ai mis en mode de présentation, vous voyez, il y a plusieurs nouvelles interventions en cours où l'OMS est en train de travailler avec les partenaires pour pouvoir vraiment résoudre ce problème de résistance. Parce que si nous avions plusieurs insecticides sous la main, la seule chose à faire, ce serait vraiment de roter ces insecticides afin d'empêcher aux moustiques de développer la résistance à une place. Lorsque nous voyons qu'il y a la résistance qui semble déjà se développer, on passe à l'autre et au fil du temps, nous revenons à ces nouveaux outils. En rotant juste de cette façon, ça va vraiment pouvoir permettre de mitiguer l'effet de la résistance. Mais comme par le passé, nous n'avions que les piétonniers, il n'y avait pas possibilité de faire cette rotation. Mais nous pensons vraiment que à partir de maintenant, il y a cette possibilité-là.
Merci.
D'accord, merci.
Merci, Raphaël. Nous allons passer la parole à Nanou Baché, qui veut certainement dire quelque chose. Nanou, allez-y.
Oui, allô, vous m'entendez?
Oui, on vous écoute très bien.
Oui, je pense qu'il a répondu déjà à ma question. Merci déjà pour son brillant exposé, mais je n'ai pas bien suivi par rapport à la sensibilisation pour ceux qui sont dehors avant l'heure de dormir. Parce que les moustiques, déjà, vers 17h, 17h30, ils sont à l'extérieur. Et comment faire pour lutter et sensibiliser les populations qui en souffrent? Merci.
Ok, merci beaucoup. Je pense que, comme je l'ai dit au départ, pour se protéger de la transmission à l'extérieur des maisons, c'est vraiment des mesures de protection personnelle actuellement parce qu'il n'y a pas encore une intervention à large échelle qui vise à réduire cette transmission à l'extérieur. Vous voyez ici, sur la diapo qui est là, ce qu'on appelle Attractive Targeted Sugar Beets. C'est un produit qui est en cours de développement et nous pensons que c'est d'ici fin 2026 que ce produit peut être recommandé. Et cette intervention vise principalement à lutter contre les moustiques qui piquent à l'extérieur des maisons. Donc, au stade actuel, c'est juste vraiment conseiller les populations de rester couverts. Il y a des répulsifs qu'ils peuvent utiliser pour éviter d'être piqués par ces moustiques lorsqu'ils sont à l'extérieur. Mais de façon, ce qu'on appelle de façon lutte opérationnelle ou lutte à grande échelle, il n'y a pas un outil recommandé par l'OMS à l'heure actuelle pour vraiment lutter contre ces moustiques qui piquent à l'extérieur.
OK. Merci, docteur. Je pense que je vais résumer les quelques questions que nous avons dans le chat pour que vous puissiez les répondre en une fois. Et il y a une question de Mariscal Brice qui demande, est-ce que l'insalubrité n'est pas une cause de résistance de ces moustiques? Bien entendu, d'autres participants souhaitent avoir votre contact et également avoir le lien de l'étude sur la résistance des ACT. Dans le chat. Je ne sais pas si vous pouvez déjà répondre à ces quelques préoccupations.
Ok, merci beaucoup, Martine. Pour l'article sur les ACT, je vais partager le lien. Pour le contact également, je peux le mettre dans le chat également. Mais si cela n'est pas fait, je pense qu'à partir de cette première diapo, ils peuvent avoir mon contact, adresse électronique, Magellan, Tchouakui, CRID.
Okay.
Ça, c'est mon adresse électronique. Donc, à tout moment, ils peuvent me contacter dessus.
Ça marche.
Okay.
Nous allons également lire la dernière question, peut-être celle qui vient de Toumaniel. Est-ce que vous travaillez, are you working on any biological trait or new species as a result of climate? If any, can it accessed?
Okay, very nice question, very nice, very interesting question. So in relation with climate, we at CRID now, we have a very big project for 8 years with Dr. Suleiman, particularly is based in Nigeria, who is trying to look at how mosquitoes try to adapt when the condition is very high. So if today we are having that high level of temperature and things like that, what are the genetic factors which will help mosquitoes to be able to survive? And also looking at if the condition is very dry, how could be the efficacy of all the new interventions that WHO is recommending, including bed nets, IRS, and other interventions. So we are really working on that. And everything we do now is trying to include that climate change, not only in the lab, but also including some of the modeling analysis to see how climate change may affect the life threats and even the effectiveness of interventions.
Okay. Thank you, Doctor. I think we are going to stop question and answer session now. It's really a teasing on how our next series of webinars will be looking like. We are going to record and save all your questions and send the answers back to you, to all the participants of this webinar. So for now, we want to actually thank Doctor for his presentation. We want to thank all the participants. Take this message home. When we are talking about webinars, about trainings, it's not just for training's sake. It's very rich and it's very important. And you, by yourself, those who have participated, I think for next time, you are going to share the link to all your network. We are thinking about all the CSOs that we are working with within the community engagement project of Global Fund, and also all the CSOs that are connected here, all the resources person connected to this training. And yes, I'm going to hand over to Fidel just in 30 seconds to give the closing remark, and we are going to meet next time. I mean, next month, at the end of next month, for another exciting topic. And I don't know if I will tell it now, but let's keep in touch as I'm introducing Fidel for the closing remarks. Thank you so much.
Merci, Martine. Je vais switcher en français pour pouvoir permettre à tout le monde de pouvoir nous écouter. Merci, docteur. C'était
c'est moi qui vous remercie, Fidèle, et toute l'équipe aussi à Somi pour l'opportunité.
Plus que vivant, nous avons relevé l'intérêt des participants à ce sujet que nous croyons un peu très compliqué, un peu entre guillemets mystique, mais vous avez réussi à démystifier la problématique liée à la résistance. Et je crois que de ce webinaire, nous avons pu éveiller les esprits à ce que nos participants, nos acteurs de la société civile, nos partenaires puissent mieux s'impliquer dans cette cause, ce problème qui malheureusement prend de plus en plus de l'ampleur, comme vous l'avez présenté à travers les différents slides qui ont été parcourus tout au long de ce webinaire. Nous voulons vous dire un grand merci aux participants qui ont pris le temps de se connecter durant environ 1 heure à 1h30 pour pouvoir échanger avec nous tous sur cette thématique très importante qui n'est qu'une première. Et nous espérons avec le temps pouvoir continuer toujours à discuter ensemble, nous édifier sur des différentes thématiques, sur différentes préoccupations liées à la lutte contre le paludisme qui nous concernent tous. Et l'une des premières, c'était la résistance. La résistance aux médicaments, la résistance aux moustiquaires utilisés. Et tellement d'études des cas ont été présentées pour pouvoir discuter de ce que des réalités vécues par les différentes communautés dans différents pays. Et nous sommes très heureux d'apprendre, de savoir que le CRID continue à pousser la recherche pour pouvoir trouver des solutions, des pistes de solutions qui pourront être appliquées. Parce qu'on a toujours encouragé ce qu'on appelle solutions locales. Et nous avons cette bel exemple à travers le travail mené par le CRID pour pouvoir définir des solutions locales propres à nos réalités qui nous permettront, nous espérons d'ici peu, pouvoir contribuer de manière conséquente à la réduction du paludisme, pourquoi pas l'éliminer, nous espérons dans les délais. Un grand merci une fois de plus à Dr Magellan pour sa disponibilité ce matin et également à tous les participants. Nous allons partager la présentation avec vous, ainsi qu'une fois aux questions avec toutes les réponses émises par le Dr Magellan. Et même pour celles que vous estimez qu'on n'a pas pu répondre, ne vous inquiétez pas, vous aurez les réponses à toutes vos questions. Merci une fois de plus à tous et une excellente fin de journée aux uns et aux autres. Je vais repasser la parole rapidement à Martine pour pouvoir pour clôturer le webinaire. Merci.
Merci beaucoup. La prochaine date, c'est le 25 juillet pour un autre thème et je ne vous dirai pas lequel. Restez scotchés à vos emails et vous aurez le thème et vous aurez qui sera la spécialiste. Merci beaucoup pour votre participation et à bientôt au mois prochain.